Okay, kiddos, let's get right into it. We're going to be doing a benchmark review for our benchmark that we have coming up next week. All right, so let's get into starting off with Unit 6. Okay, so we're going to talk about first perpendicular bisectors. So these are perpendicular bisectors. So let's break that down. What does perpendicular mean? Perpendicular means crosses at 90-degree angle. At a 90-degree angle. That's what perpendicular means. Okay, bisector means that it creates two equal parts. Okay, so let's take a look at these, right? This is a perpendicular bisector. All right, so here's the hint. This right here, this little box, tells us that that's perpendicular. Okay, all right, and then this and this being the same is a hint of a bisector. Okay, now here's a critical thing. Whenever these two are equal, then these two are equal as well. Okay, so if we know it's a perpendicular bisector, then we know that this and this are also equal. Okay, so let's take a look at this one, right? If this is perpendicular, right? If these two are equal, just like we said, okay, so we said if these two are equal, that means these two are equal. Now we can think the other way. If these two are equal and this is perpendicular, okay, then that tells us that this one equals this one. Okay, so that's what we want to take. So even if they're not labeled, that's what we want to think. Okay, so let's take a look at a problem from our recent DCP. It says AD is a perpendicular bisector of BC. Okay, AD is a perpendicular bisector of BC. If it bisects that, it means that is equal to that, right? And then we talked about if this is perpendicular and this is equal and this is equal, then that tells us that this has to be equal to that, right? Okay, so now let's look at these questions. It says triangle ADC. So ADC, this small triangle, and ADB are isosceles. ADB. Well, what does isosceles mean? That means two sides are the same. Okay, well, what do we see here? We see that one of those is the same, right? We don't see that both of those are the same. We see that one of those is the same right over here. Let me change it to a different color, right? One of those is this, one of them's that, but this is not the same, right? So we know that this one cannot be the correct answer. All right, next, this one says AC equals AB. So AC and AB, and yes, that is a correct answer. So that is our answer right over there. AC equals AB. Okay, so we do not have any, if you look at our Delta Math, so let's kind of take a look at our practice over here. We don't have any practice problems for that perpendicular bisector. Just do the we do. Now let's go and move on to the next one, which is identifying points of concurrency. Okay, so if we see over these over here, okay, we recognize that these are four different types of triangles. Okay, just depends on what these three lines are that create those. So we said those are four different things. So let's talk about what creates those four different things. Okay, so let's look at the first one over here. Okay, so we said that circumcenter. Okay, so you can get out your notes for 6.2 on this one. Okay, so circumcenter we know are created by perpendicular bisectors. Okay, so circumcenter is perpendicular bisectors. So we need something with a right angle, right? And that shows that it creates two things that are equal. So this one is perpendicular, right? And it creates two that are equal. Okay, so this is perpendicular bisector. Okay, so this one's the circumcenter. Okay, so that one's going to be C. All right, so just for our notes. All right, next, incenter. Okay, we know the incenter is created by angle bisectors. Okay, This is created by angle bisectors. Right? I'm actually going to change that to like this. Okay, so angle bisectors, that's when the angles are cut. So these are angle bisectors. So this is called an incenter. Okay, now one thing to keep in mind is, I'm going to do this a special color, the angle bisectors is the only one that has that. Okay, so keep that in mind. If you look at these, none of these other ones have angles that are bisected, right? None of these. So this is the only one. So keep that in mind for incenter. That's the only one with the angle bisector. So I'm just highlighting that a certain color so we know that one. All right, next, centroid. Centroid is created by medians. Okay, so these right here are medians. Okay, and what are medians? Those are from the midpoint to vertex. Okay, so if you see right over here, what these are from the midpoint, right? We know that's the middle because that's equal on each side to the vertex. Middle to the vertex. Middle to the vertex. Okay, so medians are middle to the vertex, and so that one is A. Okay, now the last one, orthocenter, that's created by altitudes. Okay, so that one has to be B. So these are altitudes. Okay, altitudes are when it's a right angle going to the vertex. So that's going to be perpendicular to the vertex. Okay, so those are our 4 types. So let's go ahead and get right into some practice problems. Now, what I want you to do on this one is I want to see. Let me go through this first one with you. Okay, if you know how to get this one, see if you can do this on your own. Otherwise, let's take a look. All right, it says FJ is equal to 45. So FJ, that's the whole thing. They want KJ. Okay, so let me just kind of do this. That's what they want, but this is the whole thing. All right, so what we need to recognize is what type are these? Well, this is from the middle, right, to the vertex. Middle to vertex is called the median. So these are medians. Okay? And we know with medians, they're a 2 to 1 ratio. 2 to 1 ratio. So let's go ahead and draw that. Okay? This will make it easier. We know it goes from F to J, and this is a short piece, this is a long, right? We remember say short and long. So F to J. Okay, and we said K is right there. That's the small piece, right? So we know that the whole thing is 45, right? The whole thing is 45, right? So what we need to do is put it into 3 parts. This is going to be equal to 2 of the parts. That's equal to 1, right? It's going to be that 2 to 1 ratio. 2 to 1, right? 2 to every one of those, right? So let's think about that. 45 divided by 3, that means each part is 15, right? So if this one right here is 15, then we know 45 minus 15 equals 30. That's the other part, right? And then we can think, right? Let's check our work. That's a 2 to 1 ratio. For every 2 of these, there's 1 of those. Or if we know that's 1, then we know to double it gives us 2, which is right there. Okay, so go ahead. What I want you to do is I want you to go ahead and answer this we do question right over here. Okay, and then I want you to try these next ones on your own. Okay, so if you notice right over here, this is this DCP question. Okay, so what I want you to do is push yourself. See if you can get this one first on your own. The first time you try, it's not going to count off. Okay, if you don't get it correct, then go back to here. All right, and that's what I want you to do on each of these. After you do this one, okay, if you get it correct, that's great. Go ahead and go on to this one right here. Okay. Okay, so just keep on pushing yourself to see if you can get those on your own. The first time it's not going to count off. All right, so let's go and take a look at these. All right, so this one says, in this triangle, that's the centroid, right? So centroid we know are produced by medians. Okay, so it says DZ is 2x. Okay, so DZ is 2x. DZ, right? And BD is 15. BD is the whole thing. Okay, what's the value of x? Okay, so we're working with this part right here, right? That's the median. So we know it's a 2 to 1 ratio. So let's go ahead and draw that out, right? We know it's D over here, right? We can put B over here. And which one's the short part? it looks like this one's the short part, right? So z is right over here, right? And so we know it says the dz is 2x. dz is 2x. Okay, BD is 15. So the whole thing is 15. Okay, and they want to know what's the value of X. Uh, well, that's weird, right? We don't know X, but let's think about this, a 2 to 1 ratio, right? So if this is 2X, this has to be half of that, which is 1X. Right? So now let's think part plus part equals whole. This is a little higher level, but you got this. We're going to say that this part plus this part equals this, right? So 2x plus 1x equals 15, right? So that means 3x equals 15. That means we divide both sides by 3. That means x equals 5. Okay, so we're just combining a couple things together, a couple skills together, as you might expect from this late part of the year. All right, let's keep it going. So this one says, which one of these are true? All right, so it says this is centroid, circumcenter, incenter, and orthocenter, right? So we need to see which one this is. Well, that's perpendicular, right? And it doesn't go to the vertex. It's just perpendicular, and these are in the middle, right? So that tells us these are perpendicular bisectors. Okay, perpendicular bisectors are circumcenter. Okay, so we know the one that has circumcenter has to be the correct answer. All right, let's keep it moving. See if you can get this one on your own. All right, this one says keywords incenter. We know incenter are called by angle bisectors. Okay, and this is the one that we talked about. We know the angle bisector is the only one that has this on it, right? That it has to be the angle bisector, so that's why this one has to be the correct answer. All right, let's keep it moving. All right, next. This one's on lesson 6.5. So you remember with this one basically says that in any triangle, the largest angle is across from the largest side, right? So this is 88. So if we that's the largest angle between those three, right? So that has to be the largest side. We can label that S, right? And then if that's the largest, this is the shortest, right? And that's the medium, right? And so we can go backwards as well. So if that's the smallest side, right, and that's a medium, that's a large, then across from it is those small, medium, and large angles. Okay, so that's called the angle side relationship. So let's take a look over here. All right, so we see these inequality signs, and here's what we need to remember. If they point to the left, it's going to be small, medium, and large, right? So it always points to the smallest number. Okay, so we need to think if it's large, medium, small, it points to the smallest. So it points to the smallest, points to the M. Okay, so that's what we need to keep in mind depending on which one of these they give us. All right, so it says in this, which one of these is correct? So we don't have a picture. Let's go and draw one. All right, so we know it's OPQ. It does not matter. OPQ, the order, as long as we just draw it correctly. It says measurement of angle O is 44 degrees. Okay, so we'll just say O right over here is 44 degrees, right? Okay, then it says P is 51. So P, okay, we're just going to say that's 51. Okay, next, we need to find out how much this last one is. Right? Well, we know they all add up to 180, right? So we can do 180 minus 51 minus 44. Okay, let's go ahead and type that into our calculator real quick so we can practice that. So let's go ahead and go. Make sure you're using your. Make sure we're using our Desmos Scientific like we'll practice. So we'll do 180 minus 51 minus 44, right? And we can push enter, and we see it's 85. So we know that last one's 85. Okay, so now we can label those sides small, medium, and large. I'm just going to change it to a different color so we see that. All right, so this is the largest one, right? So let me just push L right over here. Okay, this is the shortest, right? So I'm going to say that's the shortest side, right? Because we look right there, right? And then this one has to be the medium. Okay, so let's look. These are pointing this way, right? So if it's going like this, that means the largest is over here, right? Largest would be OP. So we need that to be OP. Which one has OP? That one doesn't. No. No. That has OP. That doesn't. That has OP, right? So we have eliminated all these. So if we had to guess, it has to be one of those two, right? So now let's think the smallest. The smallest is across from this, right? Shortest is PQ. So over here has to be PQ. So we know that has to be our correct answer. All right, let's keep it moving. So let's see if you can get this one on your own. All right, it says this one lists the sides of a triangle in orders from this one's shortest to longest. So we said small, right, medium, then large. Okay, so let's look. This is the largest one, right? So that's L. Okay, and this is the shortest one, so that's S, and then that has to be the medium, right? So small would be shortest would be across from that, so it's going to be ML. Okay, is less than, then the medium one is going to be KM, right? And then the large is going to be KL. All right, so let's look. We need ML first. Nope. Nope. We know ML is the same thing as LM, right? Then medium needs to be KM. That's wrong. That's correct. Okay? So let's keep it moving. Next, we're just going to move on to, this is going to be in 9.1. Okay, this is moving on to Unit 9. So we talked about in right triangles, we can use the Pythagorean theorem to describe the relationship between the two side lengths of any right triangle. I'm sorry, between the three side lengths. So if it is a right triangle, then we know that a squared plus b squared equals c squared. And here's the critical thing. This always has to be the hypotenuse, which is the longest side. Okay, so as long as we know that, then we're good. Okay, so that's the hypotenuse over there, and then those other two, are called the legs. Let's draw that. Those are called legs. Okay, so let's take a look at this one right over here. Okay, so on this problem right over here, this little picture, I'm sorry, this picture right over here, okay, we see that this is the longest side, right, because we know it's across from that 90-degree angle, right, so this one is going to be the hypotenuse, and we know that this one right here, right, and then this one right here are going to be the legs. Okay, so that's the critical thing, is that we need to make sure that we put that hypotenuse in that c squared. That's the main thing. Okay, so let's keep that in mind as we look at this first problem right over here. It says the city of Mesquite has a section of grass in front of the courthouse that's the shape of its right triangle. Okay, which of the following is the best estimate of the perimeter? All right, so perimeter, what does that mean? That means add the sides. Okay, so we need to find this. Well, we have a right triangle, so we know that we can use our Pythagorean theorem. So we know it's going to be a squared plus b squared equals c squared. Right. So the critical thing is which one is the c. Right. Well, we see that right across from that is that. Right. So that has to be our hypotenuse. So that's going to be that 12 squared. Right. So then this is going to be one of the legs. So let's just put that for a. So I'm going to say 5 squared plus, I don't know that one, so I'm going to say that's just x squared, right? So that goes there, and then that goes there. All right, so now let's do the math. We can put that in our calculator, 5 squared. Right, 5 squared. We remember that's 25. So let's put that 25 plus x squared equals, and then we have 12 squared, right? So let's put that in 12 squared. That gives us 144. Okay, now let's just solve like normal. We're going to subtract 25. Okay, so x squared equals, clean that up. I'm going to say that x squared equals, how much? 144 minus 25 equals 119. Okay, now, but we don't want x squared. We want x, right? So we need to take the square root of that, right? So let's think about that. We're going to take the square root of that, square root of that. So it's going to be equal to x is going to be approximately, let's just type that into our calculator, right? Because we don't want a radical, we want a decimal answer, right? So let's type that in, square root of 119. So that's approximately 10.9, right? 10.9. Now, a common mistake is to think it's that, right? But it's not. That's the third side. Okay, so don't be tricked by that. Okay, so then we said the perimeter is adding the sides, right? So we're going to use this plus 12 plus 5, right? We got to add those, right? So we're going to say plus 5 plus 12. So if we type those numbers into our calculator, right, we're just going to say 10.9 plus 5 plus 12, and the answer is 27.9. Okay, so that's using our Pythagorean theorem. Okay, next, a Pythagorean triple. What is a Pythagorean triple? We said a Pythagorean triple is when all sides are whole numbers. Okay, that's a Pythagorean triple in a right triangle, of course. Okay, so it says which one of these are sides that are a Pythagorean triple. Okay, so we're trying to figure out which one. So we know if we can find out this side, right? We need to find out this side. So if we're finding that out, we're going to use a squared plus b squared equals c squared. So let's set it up. We know that that's the longest side, right? We know that's the hypotenuse. That's the main thing. So now let's put 40 squared plus 32 squared. And now we can put that all in our calculator. Remember that. All right, so let's do that. So we're going to say 40 squared plus 32 squared. It gives us 2624. Right? So we're going to say 2624 equals x squared. Right? And we're trying to see if it is a whole number, right? So let's take the square root of that, take the square root of that. So let's type that in. The square root of 2624, right? I took the square root of what I found, and that is not a whole number, right? It's 51.24, right? That's no good. All right, so let's try the B. All right, so let's try that. So we'd say 5 squared plus 12 squared equals x squared, right? Because that's our hypotenuse. All right, so let's think about that. We know 5 squared, right? 5 squared is 25, right? And then we know, but we can also just type it in right here. We know 12 squared is 144, right? Equals x squared. So we can just do that in our head or do that. Now, here's the nice thing, right? So we know that we're just going to take the square root of both sides. So maybe you know in your head what the square root of 169 is. What if I told you that is a whole number? And if you're not sure, let's type that in. The square root of 169 is 13. So if we recognize that, then we would know right off the bat that that is a Pythagorean triple because that is using 3 whole numbers for the sides. All right, let's keep it moving. 30, 60, 90. This was a little tricky. Both of these special right triangles. So let's try to break it down into a more simple form. Okay, 30, 60, 90. We know that these triangles have a special relationship. Okay, so we know first we're going to say which one is the hypotenuse, right? That's across from there. These are the relationships. Okay, so we're going to say this is the short and that's the long. Okay, now we can go this way or this way, right? To go from 2x to 1x, we're going to divide, right? From 1x to 2x, we're going to multiply. We can also go from here to here. Okay, we can go from x to the square root of x squared root of 3 by multiplying, and then we can go backwards by dividing, right? So we're either going to multiply or divide. But the only thing is we don't go here. Okay, we're not going to go here. So on this one, we have to remember that we need to either start from the hypotenuse, go to the short, and then go to the long, or long to the short and the hypotenuse, just not directly from hypotenuse to there. Okay, so let's keep that in mind on this problem right over here. Okay, so this is one from my recent DCP. It says a yield sign is shaped like an equilateral triangle. Okay, that has sides that are 36 inches long. Which of the following was closest to the height of the sign? Okay, so this is a higher level question, but we got this. So equilateral tells us all angles and sides are equal, right? So that means this has to be 60, right? That has to be 60. That has to be 60, right? And then so if those are 60 and we're just finding the height, right? Do that blue. Height, right? That would make this a 30. So now we have, if we look at it like this, 30. We know that's 90. And then that's 60. 30, 60, 90. So let's take a look. If this is 36 right over here, right? This is half of that, right? So that means that much is 18, that much is 18, right? So let's do that. They want to know this, which is the long side, right? Because this is across from the 30. That has to be the short side. That's the hypotenuse. So we're going to go from the short to the long, right? Short to the long. We said to go from short to long. What did we say? To go from short to long, we're going to multiply, because it's bigger, times the square root of 3. So we're going to take that short, which is 18, times the square root of 3. But those aren't our correct answers, right? So we need to use Desmos. Okay, that's the key of using this tool. So let's go and just type that into our calculator. Right? We're going to type in 18 square roots of 3. Okay, so this is very important that we can use for a test taking strategy. We know 31.17 is approximately that right there. Okay, so it's going to be 31.2. Okay, so we use Desmos on that. Okay, and that takes a really tricky one into something simple. All right, let's take a look at this one. It says which one represents the length of AC? Okay, so AC is this right over here. Okay, I know you have a bad copy, but that's 30 degrees. Well, if that's 30 and that's 90, this has to be 60, right? Because they all add up to 180. Well, if that's 30, 60, 90, they want to find out this. Let's label that. That's the hypotenuse. That's the short. That's the long, right? So what do we have? We have the hypotenuse, and we're trying to find AC, right? We're trying to find the long. So we said we can't go from the hypotenuse directly to the long. No. We're going to go from the hypotenuse to the short by dividing, because it's shorter. Then we're going to multiply. So we're going to say if the hypotenuse is 12, we're going to say the short is equal to hypotenuse, right, divided by 2, which is equal to 12 divided by 2, which is equal to 6. Okay? Now we said the long is equal to the short times the square root of 3. That's going to be equal to 6 times the square root of 3. And that is our answer, 6 times the square root of 3. All right, so hopefully that's making more sense now. 45, 45, 90. So this is a little bit different. Now this one has two sides that are the same. Okay, so that's going to create, we can do it like that. These are isosceles triangles. Okay, so we said two sides are equal length on an isosceles, right? So we know if these two angles are the same, right, then we know the sides across from them are the same. So we can go from here to here, or from here to here, right? And then even from here to here, right? If we know one of those, then we know the other one. Okay, so let's keep that in mind. It says, what's the length of PR? PR is right over here. Okay, well, what do we know? That's 45. If that's 90, this has to be 45 as well, because they have to add to 180. If that's a 45, 45, 90, if this is the hypotenuse, we're trying to find the hypotenuse given the leg. So if we have the leg, we either said multiply or divide, right? So we're going to multiply times the square root of 2. So that's going to be x equals 7 times the square root of 2. So that's our answer. Okay, could be as simple as that. All right, so we have another problem. Oh, it didn't come up on this. It's okay. All right, so we'll come back to that one. All right, next, let's look over here. A fence around a square garden has a perimeter of 48 feet. There was one more problem that didn't get on here, but think about moving backwards and do the best you can on that. I think you can get that. All right, a fence around a square garden, okay, has a perimeter of 48 feet. What's the exact length of the diagonal of the square? Ooh, that's tricky. Let's draw what we talked about. Okay, it's a square, so we know all those are 90 degrees, right? It's a square. And if it's 48 for the perimeter, that means all sides are, if it's a square, all sides are equal, right? So if it's 48, we divide by 4, which is equal to 12 per side. Right? So if that's 12, that's 12, that's 12, that's 12. Okay, it says, what's the, right? So that's what we know from that information right there. Okay, what's the exact length of the diagonal? Diagonal is something that looks like this, right? Well, what do we know? Let's think of it like this. That's 12 and that's 12. That means this has to be 45, right? Because we said anytime that a 90-degree angle is cut in half, these are each 45 and 45, right? 45 and 45. So now we have a 45, 45, 90. So we're trying to find out this length. Well, what did we say? If we have that length, we just multiply it times the square root of 2, right? So x equals 12 times the square root of 2. And so our answer is D. All right, so hopefully getting the even better hang of that one. Let's keep it moving. All right, so now we're going to talk about what we talked about most recently. So we talked about trig ratios and inverse trig. Okay, so trig ratios are used to find side lengths, right? And then inverse trig is used to find angle measures. Right, so how large an angle is. Okay, so we talked about those three ratios: sine, cosine, and tangent. Okay, so we said that sine, right, of a certain angle, right, this is a angle that goes right there. Sine is the opposite over the hypotenuse, right? And then we said the cosine of a certain angle is equal to the adjacent over the hypotenuse, right? And then we said the tangent of a certain angle is equal to the opposite over the adjacent. Okay, so those are those three ratios, right? And then inverse to work backwards. So if we're trying to find the angle measure, right, that's going to be x. We're going to type this in. The inverse sine of the opposite over the hypotenuse, right? And then to find the, if we're working with the adjacent and hypotenuse, then we use inverse cosine, right? If we're working with the opposite and the adjacent, then we use inverse tangent, right? So that's what we're going to remember. We're going to remember SOH, CA, TOA. Okay, that will be how we remind ourselves. All right, so let's take a look. Okay, it says the top of the Bolivar of Arts Lighthouse in Texas is 116 feet above the sea level. Angle of depression from the light on the top of the tower to a passing ferry is 37. How many feet from the bottom of the lighthouse is the ferry? So that's what we're trying to find. That's our x. Well, what did we say about angle of depression? The hint is change to angle of elevation. Okay, so that's our hint. So we're going to change that to this being the angle of elevation. So use that instead of thinking of it like that. Right, so now let's think of it. So that's our 90 degree, right? Change that color. This has to be the hypotenuse, right? And then from this perspective, right? So from the 37, this has to be the opposite side, and that's the adjacent, right? So to find that angle measure, we're going to use tangent. So we're going to say the tangent of 37 degrees, right? Because we said to find the side length, we're going to say the tangent of a certain angle measurement, right? Tangent of measurement is opposite over adjacent. So 37 is 116 over x, right? And now we can drop that over 1. We're going to do our cross multiplication, right? So x times tangent of 37 is written as x times the tangent of 37. Okay, so that was a little tricky as we first started, but then we remembered x goes first. So that goes to the first, and then we remember it's tangent 37 equals this times this equals 116. Okay, now think about what we're trying to do. We're trying to get x by itself, so we're not going to divide by 37. That would be a common mistake because then that would just go away. We're going to divide by tangent 37. Right, so tangent 37 both sides. So then I have x, and then let's type that into our calculator. Right, so let's just go over here. We want to make sure it's on degree, right, and we're going to push tangent. Oh, no, I'm sorry. We're going to push this a over b. Let's just do this. Okay, we're going to a over b, 116 over tangent 37. Okay, 153.93. 153.93, and that is our answer right there. Okay, so just remember on angle of depression, change it to angle of elevation, and then go from there. Okay, next, let's look at this right here. Aaron wants to find the length of PN. PN. Okay, so PN is going to be this right over here. Okay, so if she's trying to find out which one of these can she use, right? We want to see which of these ratios, two of them or a combination or what. All right, so let's look. Let's just try to see if these are correct. Sine of 34, right? So sine we know is opposite over hypotenuse, right? So sine of 34 would be equal to, so from the perspective of 34, right? Perspective of 34, we'd say opposite over hypotenuse, right? So we'd say x over 7. Okay? And that is true. Good. Let's look at cosine. We said cosine is adjacent over hypotenuse, right? So we'd say cosine of 56 is equal to, because that's what they're giving us. Let's see. The 56 is right here. Cosine, so adjacent would be x, because that's opposite, right? X over 7. And that's good too. All right. Next, tangent of 56. So tangent we know would be opposite over adjacent. So we'd say the tangent of 56, if that was correct, we'd say the opposite of that 56. We don't have a label for that, right? Over the adjacent of x. So that means that's wrong. So only 1 and 2, so B is correct. Okay, keep it moving. See if you can get this one. All right, so this is given this triangle. TP is 35 and PA is 20. Okay, what's the closest to the angle measure, right? So this tells us inverse trig, right? And also because we see all these have degrees, right? That means it's an angle. So let's think about those sides. So from this perspective, right? So this is going to be our x, right? That's what we're trying to find. Then we know that this is hypotenuse, this is opposite, this has to be adjacent. So we're working with the opposite side, right, and the adjacent side. So we're going to say the tangent, x is equal to the inverse tangent, right? Because we're trying to find the angle measure. Inverse tangent of, right? We remember tangent is opposite over adjacent, right? So opposite, so 20 over the adjacent, which is 35, right? So now let's just type that right straight into our calculator. Okay, so we remember first off that we have to use this function button over here to go to the inverse, right? So we're going to say, oop, it doesn't matter. Actually, whenever I mess up like that, I can just push that and then it goes back. All right, so we're going to say inverse tangent of 20 over 35. Go back to main, do that, 20 over 35. All right, 29.74. Okay, so that's going to be 29.74. Actually, approximately right. 29.74 gives us the answer of F. All right, let's keep it moving. It says find Km to the nearest tenth. Km is a side. All right, so that means we're going to use trig. Okay, now let's look from this angle's perspective. What side do we have? We have, this is our hypotenuse, so that has to be opposite. That has to be adjacent, right? So from that, we're working with the what sides do we have? We're trying to find the opposite and the hypotenuse. So we're going to use sine. So we're going to say the sine of this angle measurement is equal to the ratio of the two sides of, we said sine is opposite over hypotenuse. So, right? So we're going to say the opposite, which is what we're trying to find, over the hypotenuse, which is 40. Right? So now we can just drop that over 1. We can cross multiply. Right? So we know x is equal to, we're going to here's the thing, remember it still is the sine of 32, right? So it's 40 times the sine of 32. So we're going to write the 40 first, then the sine of 32. Okay, we recognize that's not one of the answers, right? So let's type that into our calculator and get that value. So let's just type in sine 40 sine 32, and it gives us 21.19. X is approximately 21.2, right? 21.2. All right, I know we went through a lot, but now we're going to our last page. This was a little tricky, hopefully, for our last test, but hopefully this will become easier with this. So the geometric mean. Okay, so the geometric mean is when we're talking about this right over here, that guy, which is called the altitude. Okay, we know the altitude is perpendicular to the vertex. Okay, this is perpendicular to that vertex, right? And so here's how we calculate that, right? So if we're trying to find that value, that right over there, we're going to say that this creates two parts. Okay, so this one is going to be part number 1. Okay, and then this one right over here is part number 2. Okay, so we have that altitude, right? And it cuts those pieces, that hypotenuse, into two parts here. And here's how we set it up. Okay, we're always going to set up, and we're going to say the hypotenuse. I'm sorry, not the hypotenuse, sorry. Altitude on the bottom of one and altitude on the top of the other. Okay, then we're going to have the part number 1 on one and part number 2 on the other. Okay. Okay, so that's all we do. We're just going to set it up just like that. So let's take a look at this. What's the length of CD? Right, we're trying to find the length of that. Well, what do we know? If this is a 90-degree angle and that's the vertex, then that's the altitude. Right, and we're going to say this is part number 1 and this is part number 2. Right? Part number 1 and part number 2. So let's just set it up. Okay, we said the altitude, right, goes one on the top, one on the bottom. So if that's what we're trying to find, that's x, right? And then we said the part goes on one and then the other part goes on the other. Now let us just cross multiply, right? So I like doing my x's first. X times x is x squared equals 16 times 8. Let's type that into our calculator. 16 times 8. Okay, that gives us 128, right? But we don't want x. We don't want x squared. We want x, right? So we got to take the square root of that. Got to take the square root of that. So that means x is approximately, let's type that in, 128, 11.31, right? But that's not one of our answers, right? So here's how we can do a test taking strategy. Let's type that first one into our calculator, 8 square roots of 2. Okay, so let's go over here. Type 8 square roots of 2, and that gives us the same answer. So since that was the same, that's how we know that that's the correct answer. Okay, so type into Desmos. That's how we can use it as a tool for a multiple choice. All right, so now here's going to our highest level question out of all these. See what you can do on this, our last one. Okay, so it says, what's the distance from the entrance to the pond? Okay, so this one you kind of have to look over. Here's the pond, here's the entrance, right? So they want us to find this. Okay, well, what information do they give us? They give us this and this. Okay, well, let's think of a problem solving. Let's think of, we can find the altitude right? If I can find this, and say I label that y, then I'll have, if this is a right angle, right, then I'll have two sides of a right triangle. I can use the Pythagorean theorem for find that third side. All right, so let's do step number 1. Okay, so let's set that up. We said the altitude on top on one and bottom of the other, right? And then let's put 25 on top and 10 on the bottom. Okay, right? Now let's cross multiply. Okay, so y times y gives us y squared equals 25 times 10 is 250. Right? So now we know we need to take the square root of both sides, right? Square root of that, square root of that. So y is approximately, if I type that into my calculator, 15.8. Okay, but that's not our answer. So this is trick question. That's not correct, right? That's if we looked, if we weren't paying quite attention as we needed to. Now that we know that, let's think about that. Now we have, if you think of it like this, right? We said that's 15.8, and this is 10. So now we just need to figure out this, right? That's our x. So that's our hypotenuse, right? So let's think about that. 2 said a squared plus b squared equals c squared. So c squared is what we're trying to find, right? So we're going to say 10 squared plus 15.8 squared. Now, let's just put that into our calculator, and that's going to be equal to x squared, right? So let's do that. So we're going to say 10 squared plus 15.8 squared is 349.64. Okay, but we don't want x squared, we want x, right? So let's see if that was a wrong answer. No, that wasn't a wrong answer. So let's take the square root of both sides, right? Come on, we got this. See if you can get the right answer before I do. So that means x is approximately, let's put that in our calculator, right? So we're going to say the square root of 349.64 is 18.7. 18.7, and that's our correct answer, 18.7. Okay, so I know we went through a lot of stuff, but I want you to make sure that you go through those practices on that Delta Math. Okay, preferably I like you to do it after each practice. So, for instance, right over here, after we did those points of concurrency, I wanted you to try these on your own. Okay. After you did the angle side relationship, I want you to try that one on your own. All right, so get those done. Let me know if you have any questions, but make sure that we get this done before our DCP, which will be next class.